Sims, you just won the Super Bowl. What are you doing next?
I'm going to go to Disney World.
Washington Redskins just won the Super Bowl. What are you going to do next?
I'm going to Disney World!
And greetings. Welcome to the Evidence and Reasons for the Christian Faith channel. I'm Salvador Cordova. It says in Proverbs 25:2, it is the glory of God to conceal a matter. It is the glory of kings to search out a matter. And it also says in the New Testament, the kingdom of heaven is like a treasure hidden in the field. The reason that we study on this channel Evidence and Reasons for the Christian Faith is that God has chosen not to make his existence and the Christian faith as obvious as the air we breathe. If God spoke from the skies and with a thundering voice and said, hey, this is who I am and this is what I did, we'd probably be more inclined to believe. But God has made it such that a lot of knowledge about him is hidden and requires us to search it out, just as it says in Proverbs 25:2. It's the glory of God to conceal a matter. It is the glory of kings to search out a matter. Here on this channel, one of the ways that we explore the Christian faith, evidences for it, is through the study of science, really more formally using the scientific method to evaluate the evidences for and against special creation, and for and against the idea that there is an intelligent designer of the universe and life. Secondarily, it raises questions about the timeline of creation. There are some people that are old earth creationists and then some that are young earth creationists, and there are ideas about Noah's flood. In addition, there are some who would consider themselves intelligent design friendly theistic evolutionists. So there are some theistically inclined, intelligently designed there are some theistic evolutionists who are sympathetic to intelligent design, like Michael Behe, or actually even proponents. And then there are old earth creationists, which automatically mean they accept some form of intelligent design. And then obviously young earth creationists accept intelligent design. So there's a common thread among those three viewpoints of intelligent design. That being said, it's healthy to understand the various origin theories that are mainstream secular, and each person has their theological views about how to interpret the book of Genesis and other parts of the Bible, and I want to respect that. On the other hand, I think that sometimes the study of the physical evidence might give us a clue how to better interpret the scriptures. So there was a time when people would interpret the scriptures to say that the earth is flat, or I don't know that there are many, there's still some today that do that. And there definitely was a time when people like John Calvin and a certain pope insisted that the universe basically revolved around the earth, what we call the geocentric model. And we found by using the scientific method to make observations and to make testable theories, we concluded that the solar system is actually, that the earth is part of a heliocentric system, and the universe is not geocentric. So now the question of origins is now being affected by theories like the theory of evolution, the Big Bang. And whether one is an old Earth creationist or young Earth creationist. By the way, I'm a young Earth creationist. I profess the evangelical faith. I have definitely Reformed leanings. I don't self-identify as a Calvinist. I identify as a Bibleist. So if the scriptures use the word predestination or the elect, I accept that. That's kind of my theology. So that being said, I think it's helpful to evaluate. Well, maybe is the Big Bang true, or are our dating methods correct? I'd say that there are question marks for the mainstream viewpoint. There's certainly question marks for young Earth creationism, and there are question marks in just about every model that's out there. My hope is that by studying the experiments so far and the observations we've made, comparing it with theories and how the theories have fared over time, we can come closer to having some idea what is closer to the truth. So, all right, I was just checking my audio here just to make sure that the audience can hear me. So today I'm going to look at some papers. I'm going to review some papers. I'm going to review some articles. The talk of today is The Cosmic Revolutionaries Handbook, How to Beat the Big Bang, first edition. So let me try to get all this queued up here. This is always a challenge to get queued up. Give me a moment here. I have a whole lot of documents on the docket. And, okay. Let me put this here. Now, I don't have the whole book, so what I'm going to do is I'm just going to read the Forbes article. Wrong. Bad on me. Sorry. I'm getting acclimated to using StreamYard. It has a lot of quirks. It's very powerful, but it does have its challenges. So I'm going to have to keep refreshing this page because it's going to keep putting that advertisement wanting me to subscribe to Forbes. Is it time to dethrone the Big Bang Theory by Jamie Carter? And this is the title of the essay, but it's really talking about this book by Luke Barnes. In cosmology, the Big Bang Theory is king. It wasn't always that way. And here we go with these advertisements. But over the years, evidence is mounted, and for the most part, astronomers are convinced it's the best we have. So why do so many people hate it? Black holes, invisible dark matter, and the idea of the cosmos being born in a millisecond defy plain common sense. Sorry for those obnoxious ads. Frustrated by people telling them how to do their job, two astronomers set out to answer the questions and criticisms they are so frequently sent. The result is the Cosmic Revolutionaries Handbook, or How to Beat the Big Bang, which sets out exactly. I'm going to quit this in a little bit because it's getting obnoxious. what any Big Bang Theory hater needs to explain before a new theory can begin to take hold. As cosmologists, our job is to explain the universe as a whole, its structure, constituents, and evolution, said Dr. Luke A. Barnes. Barnes is a postdoctoral researcher at Western Sydney University. People email us with their ideas about the universe, how the universe works. And while we love their enthusiasm, we found ourselves sending the same kind of reply over and over again. In the book, Barnes and colleague Professor Geraint F. Lewis, Professor of Astrophysics at Sydney Institute of Astronomy, part of the University's of Sydney School of Physics, explains that while science isn't perfect, nor is it arbitrary. Boy, Forbes ought to love me for giving them all this free advertisement. The result is a plan for overthrowing the Big Bang Theory, which details exactly what any challenger needs to explain before proposing a new kind of theory. The point of the book is that the Big Bang Theory has a solid track record of explaining well-established facts about the universe, said Barnes. If you want to challenge the Big Bang Theory, you better be able to explain the basics before you have a shot at explaining mysteries like dark matter. They also stress that because astronomers measure the universe, any new theory better have some maths in it somewhere, as well as distinct lack of fonts, formatting inconsistencies, and rants on social media. And that's what the book is, by the way, the Cosmic Revolutionaries book. At its core, the book tries to explain the messy business of how astronomers came to believe in the Big Bang in the first place. The real core of the Big Bang Theory is this. In the past, the universe was hotter, smoother, and I'm going to quit this in a little bit, guys. This is too much. Said Lewis, that's what generates precise scientific explanations of the universe we see around us. Many people think the theory says our universe began by exploding. All right, so I'm just going to quit this here. This is getting to be too much. And Paul Kamish is here. So since I have a visitor, Paul Kamish asks, and by the way, guys, sometimes I will miss a lot of comments in the side chat when I'm doing a show solo. That's why it's nice to have a team here. And then also, unlike I'm using Streamlabs right now, I can't post a comment right there on the screen like I do with Restream. So I'm just going to have to read it. Paul Kamish asked, why do you think the Big Bang and evolution is why atheists don't believe in God? If both were disproven tomorrow, it wouldn't make any difference to me not believing in God. Because some atheists have said that, so I think you're right to say that it won't apply to you. So there's certainly some atheists that resist the idea of evolution being proven false, and also really abiogenesis. You need to get good evidence for God. What, to persuade you? I'm not here to persuade you. I'm actually trying to find out if you guys, people like yourself, Paul Kamish, and I'm assuming you are an atheist, can persuade me that life in the universe weren't miraculously created. Because if life in the universe were improbable, that would suggest a miracle created it. Miracles require miracle makers. Now, if that line of reasoning doesn't float your boat, then I'd have to ask, what would count as evidence for God that would persuade you? Some people say, well, I'd need to have experiments that I could run that could prove God. So what sort of experiments would you run? Would it be that you demand God to appear right before you at a certain time and place and participate in an experiment? If you could do that and command God to do whatever you want, whenever you want, how many times you want it. Effectively, you're God. And I recognize at that point you could be a believer because you're effectively God. But a God who created the universe doesn't have to cater to your whims. And so even if he exists, given some people's viewpoints that they demand experimental direct evidence, maybe even if he is real, what he's provided is not persuasive to you. However, it is persuasive to some of us. Because I find abiogenesis theory utterly ridiculous. I find eukaryotic evolutionary theory totally unfounded, and it seems like a miracle is a better explanation. So, by the way, is the origin of the universe. I should point out, since Luke Barnes is the author, the co-author of this book, he is a devout Christian, and enough of his writing suggests that his viewpoints about the existence of God are strengthened. And I've heard him speak, I've interacted with him personally through Zoom, that his scientific studies have reinforced his view that a God exists. Obviously, he's friendly to the Big Bang cosmology. So let me go to the Amazon, see if I have the Amazon link. Maybe that would be a better thing to show. No, let me see if I can get that Amazon link. The Cosmic Revolutionaries Handbook, or How to Beat the Big Bang. So let's look at some endorsements here. By the way, you can download for free the samples of the e-textbook and see if they have some nice endorsements here. Dr. Sunny Vagnozzi, Nature Astronomy, the Cavill Institute of Cosmology, Institute of Astronomy, University of Cambridge. Dr. Chris North, BBC Sky at Night magazine. Ogden Science Lecturer and FC Public Engagement Fellow at Cardiff University. Prayam Vada Natarajan, author of Mapping the Heavens, The Radical Scientific Ideas That Reveal the Cosmos. SEAN CARROLL, overthrowing all of modern cosmology isn't easy, but it could happen. Okay, guys, it could happen. If you're up to the challenge, Luke A. Barnes and Geraint F. Lewis tells you exactly what you have to accomplish. Even if you don't topple the stodgy edifice of modern science, that's a misquote. It's not an edifice of modern science. You don't need the Big Bang to do science. You'll certainly learn some exciting things about the universe along the way. And Paul Kamish says thank you for your answer, and Paul Kamish, thank you for your question and comment. Much appreciated. So, what the book, and really the Forbes article, and maybe no need to rehash it, it talks about basically the same things that I put forward yesterday about the problems with Big Bang Theory. Some of the ones off the top of most people's heads is dark energy, dark matter, inflation. Now, let me see if I can get this right. Fundamentally, the Big Bang, at the base of the Big Bang Theory, is the idea that the universe is expanding. Everything else proceeds from that. Now, if the universe is expanding, it causes some other problems that need to be patched up, like what they call the flatness. Flatness is the lack of curvature in the Einstein tensor, not the Einstein tensor, the Friedman, Lamarck, Robertson, Walker solution or tensor to the Einstein field equations. I may have gotten some of the terms wrong. It's been a while. And there's supposed to be like whether that, okay, that's the expanding space, but is the space flat? And the meaning of flat's a little bit difficult to conceive of in 4 dimensions or whatever number of dimensions are involved. Again, it's been like 10 years since I've done cosmology and general relativity. I'm going to have to take the dust off some of my textbooks. So inflation supposedly solves the flatness problem. Also, the uniform temperatures, the near uniform temperatures of the supposed cosmic microwave background radiation, and it's not well known, but it supposedly solves the magnetic monopole problem. But inflation has to invoke that space suddenly starts getting inserted between matter, and then the matter then effectively, without feeling acceleration, moves at speeds faster than the speed of light. And if you can buy that, it's like, well, that seems kind of sketchy, and we certainly have no direct proof of this. It's just a theoretical construct with no experimental or observational independent confirmation outside of just supposing it is. I mean, I was thinking when I was studying this, I said, if you can invoke things that do that level of magic, you can invoke God, God who works miracles. It's not, if you don't have some experiment or real theory, at that point it's still just kind of a faith statement. It might be true, but it's still just a faith statement that you cannot derive from anything experimentally or really observationally directly, because those properties of the universe can just as well be attributed to other theories. Some of them are like variable speed of light. Andrew said that's not how cosmic expansion works, nor cosmic inflation works, though, Sal. All right, you're welcome to explain it in the side chat, what inflation is and what it solves. I just said that it solves the problem of flatness, the problem of even temperatures, and the problem of magnetic monopoles. The expansion rate is thousands or millions of times the speed of light. Oh, okay, semantics. It's being separated. If you just want to use, okay, that, I would just argue that's semantics, because this problem was noticed when the objection was, how can this be moving faster than the speed of light? You're also, I guess, violating some conservation laws if there's, as far as potential energy, because now you're adding distance. So I'll grant that objection. I think it's kind of petty, but we'll move forward. So that's the second layer. So first is the expansion of space, and then the inflation model, where the expansion gets really fast. And then the next one of the levels is nucleosynthesis. The next level is, another level is the dark matter, which I'm told was originally for accounting for the motions of the galaxies, but it also helps in the formation of the galaxies. Michael Disney puts that as part of the layers of the Big Bang. And then finally, the dark energy. So dark energy is definitely kind of the weakest link in this. It's meant to explain the supposed acceleration of the expansion. So this looks really kind of funny. You have an expansion that was accelerating, and then it stopped. Now it's accelerating. And then that also puts us in a privileged position, and Lawrence Krauss has argued Lawrence Krauss has argued then that we are in such a special point of time in the universe's history that future observations will actually come to the wrong scientific conclusions. When everything's separated far enough, we will start to lose causal contact. And it's like, philosophically, are you willing to accept a theory that predicts that science will actually fail at some point? So, oh, well, Andrew says the universe is already expanding faster than the speed of light. Can you swallow that? So I'll take that quote. So now let me look in my docket of things to cover. So I think I'm going to cover, since the first level is the expansion, I'm going to read from Edward Hawkins, and I want to give a hat tip to Mr. Jetty89 for sending me this document. And it talks about the fact that there's no independent evidence that the redshift implies expansion. And Hawkins, who published in the monthly notices of the Royal Astronomical Society in 2010, he pointed out that his observations seem to disconfirm the redshift as an indication of expansion. So let me see if I can bring this up, because then it's going to cite some other papers that criticize the assumption that the redshift is quote-unquote Doppler, and I use that kind of somewhat loosely. Oh, logical, plausible. John Maddox. Okay, let's see. John, you can liven this up. I mean, if you want to join, you can. I can send you an email. You'll see an email from me if you want to come on board. Andrew Cummings says this is in complete accordance with special and general relativity. I need to point out, just because something is mathematically in accordance or a solution to the field equations of general relativity doesn't mean it's correct. Any more than if we use negative mass in Newton's second law of F equals ma, where you use negative mass, it may be mathematically valid, it's not physically valid. And there are examples, like, say, wormholes. I was working, we were assigned to study the geodesics in wormholes, and then after we labored through the week, the professor said, well done, guys, but by the way, I don't think this will work. You need negative mass. So just because it solves the Einstein field equations or provides a mathematical solution doesn't mean the solutions are even physically realizable, much less correct. So just say something, LPP, if you want to join, and I'll send you an email. But in the meantime, I'm going to read this. On time dilation and quasar light curves. In this paper, we set out to measure time dilation and quasar light curves in order to detect the effects of time dilation, Sets of light curves from two monitoring programs are used to construct Fourier power spectra covering timescales from 50 days to 28 years. Data from high and low redshift samples are compared to look for changes in expected from time dilation. The main result of the paper is that quasar light curves do not show the effects of time dilation. Several explanations are discussed, including the possibility that time dilation effects are exactly offset by the increase in timescale of variation associated with black hole growth, or that the variations are caused by microlensing, in which case time dilation would not be expected. So he'll go through this. Now, what I want to point out, and this is a good paper, and I want to hat tip Mr. Jetty for providing it. One of the difficulties looking for correlations, let me see, I want to see the reference to Foley here. Crawford and Foley. I'm going to move. I think it's down in the conclusions. I want to see, where did he have Foley? Let me search for Foley. Okay. The light curves of distant supernova provide a much more promising test for time dilation. This is what Andrew brought up yesterday. Early work by Goldhaber et al. 2001, which involved measuring the light curve widths of a sample of distant supernova covering a wide range of redshifts, provided convincing evidence for the presence of cosmological time dilation. More recently, Foley et al. 2005 have examined in detail the spectral evolution of a high redshift supernova and shown that it is not consistent with no time dilation, at the very high confidence level. And, all right, let's look at Crawford. All right, as mentioned in section 1, searches for time dilation in gamma ray bursts do not provide a conclusive test. Supernova light curves, on the other hand, appear to show convincing evidence of time dilation, Foley et al. 2005, which would rule out a non-expanding universe as an explanation for the result presented here for quasar light curves. Although this result has been challenged in an interesting paper by Crawford 2009, on the basis of bias in the sampling procedure, it seems fair to say the result is the result is still generally accepted. So I'm going to look at Crawford's paper. He's saying that this is bias. And then I'm going to also offer my reasons, one alternative mechanism of the redshift that only happened in 2021. The paper was only published in 2021. So while I set this up, give me a moment and I'll talk a little bit. So 2021. So let me go back to my docket here. There's so many papers I'm going to have to go through. So I want to thank Mr. Jetty again for the Hawkins Quasar paper. So now let's look at David Crawford, just to introduce who the gentleman is. Now, I heard the word Sydney for Luke Barnes. Let's see, Luke Barnes. Oops. David Crawford is the University of Sydney. Let me find out where Luke Barnes is. This would be interesting. Again, Luke Barnes is a Christian. He thinks that fine-tuning and the Big Bang, at least his writings. Okay, Luke Barnes is the University of Western Sydney. Western Sydney University. So I don't know the difference. So David Crawford, I think this is the right David Crawford, David F. Crawford, University of Sydney School of Physics. So now I'm going to try to get his paper going. Let me go to, if I could find it now, his paper. And by the way, the links I'm showing, the things I just showed, the links are in the video description of this stream. So now I'm trying to load the, there were actually two papers that were both released. And it is true that this is generally rejected, but, well, you want to hear the other side, here it is. AIP, that's another physics organization. New analysis, let me get this. New analysis, let me get myself out of. New analysis of observed high redshift supernova data show that a majority of SN1A, that's supernova 1A, decay light curves can be shown to favorably compare with a non-dilated rest frame template. New analysis of observed high redshift supernova data show that a majority of supernova decay light curves can be shown to favorably compare with a non-dilated rest frame template. So the way some people can approach this is they'll say, okay, it's not peer-reviewed, or he's of bad reputation. And my thing is, if you're a trawl in a basement who's burned your brains out with drugs and alcohol and you're a high school dropout, if your arguments are good, they should be accepted. So my policy is if the arguments are good, you should be accepted. It might be a heuristic that you don't listen to certain people if they don't have at least some credentials. But ultimately, that's not the measure of it. So I do find it ironic that someone with no credentials is insisting on using credentials. That's just not very good for, that's not really a great way to argue. So I'm going to just say, if you don't like his credentials or the fact it's not in a top tier journal, all right, you can, if your policy is to just write it off, go ahead. But if you want to investigate it, it's here, and you can consider the arguments based on the evidence provided and the reasons for an interpretation. And I'm happy to say, a lot of this is over my head, even though I've studied cosmology as far as classes, but that's not the same as really being a researcher in the field. But let me read the abstract. The supernova 1A data to date has been shown to compare favorably with time dilation in those predicting an expanding universe. Okay, so to date, he's just saying that's the way it's been. However, it is also true that these best fitting methods used to date only test for dilation, and at no time has any study tested the supernova data to see if the non-dilated template can give comparable results. The incorrect conclusion from these papers is that a good fit for the data rules out any similar result for non-dilated fitting procedure. In this paper, the HST, which is I think the Hubble Space Telescope, and ground-based data from 11 high redshift supernova are best fitted to undilated and dilated rest frame composite light curves. The conclusion is that the majority of redshift SNE1A data can be shown to exhibit no time dilation as well as shows time dilation. So what he's saying is basically you're selecting data points that would reinforce your viewpoint you're excluding data points that would falsify your viewpoint. That is extremely bad science. So just take it or leave it. If you want to go by the route of argument by authority and argument by consensus, what they call argumentum ad populum, you know, that's your choice. We all can't be experts in every possible field. And I'm just going to point out at that point, you're trusting faith that the consensus is telling you right. It is a faith statement. It is not one built on your own level of knowledge. And really, to a lot of degree, all of us have to are trusting in our sources of explanation. So let me see here if I can get the PDF. I should have downloaded the PDF. I'm sorry. So I'm going to try to get the PDF now. See if I can get it. And I hope I don't get... I don't know why I was able to get... All right, I have the PDF downloaded somewhere. Okay, hang on, guys. This is important enough. I want to do this right. So the PDF, Hawkins, Crawford. Okay, I got the PDF here. It's going to take me just a little bit to get it going. And while this thing is spooling up, Leo says, nobody's excluding data points that would falsify the model. Well, I think that's what the claim is. He's somebody. I mean, Dr. Crawford seems to be somebody. So let me see. Let me try to do a screen capture instead. And again, all right. So I'm going to try to get this a little bigger. So I think, okay, you can read the abstract. I gave you the link at least to the abstract. Now that it's going to a paywall, I actually don't know how I got this paper. It somehow filtered to me. So greetings, Leophilus. I'm sorry, didn't mean to. Leophilius. So greetings, Andrew and Leophilius and Straight Talk TV. So here's the PDF, and I'm going to show you. You can go through it, but there is a graph here where he shows. Okay, he took all the supernova data points, and you could see only one line there gives you the time dilation. Most of them are not there. So what he is suggesting then is all that this study had done that supposedly proved time dilation was figure out a clever method of picking the ones that give you the data you want. So you filter out all this, and you only report this. That's it. Okay, so if you know, I think, and this is something that applies to me. And you know, not everyone has limited resources and time in their lives to do things, and I respect that. What I did when I saw these questions of biology and cosmology way back in 2003, I resolved that I would go to school. And it wasn't fun going to school when I was working full-time and get degrees in biology and physics. Does that make me an expert? Absolutely not. I know squat. But I at least know the arguments a little better. And if someone really, really wants to settle this in their own heart, they can either go by the route and saying, oh, this is the mainstream consensus, or they could actually go to the data points. So for myself, I'm now more convinced than ever that abiogenesis is, naturalistic abiogenesis is baloney. So is eukaryotic evolution, and at least I've done as much due diligence as I could for myself. So the paper's there, and I would welcome if anyone wants to criticize it from the standpoint of methodical evaluation of the data points. You look at his materials and methods, so to speak, and then you see if his criticism of filtering out data. So this line here, I think I'm going to have to shut off this Zoom thing. How's my audio coming through? So just look at this graph here. I mean, there are a lot of supernova. Are you just going to take the ones that are on this line that indicate expansion? That's what he's arguing. And all I could say is, if you are thinking this is wrong, I've heard all sorts of stuff saying this is crackpot, it's not in a top-tier journal. It's like, okay, fair enough. Fair enough. If you don't think he has the reputation, then maybe you can find some trawl in a basement who is a high school dropout, but if his arguments are good enough, you should follow it. So this is worth following, guys. I can only lay it out here. Oh, thanks for the feedback, Andrew. It says audio is good. So do I have time right now to do this? No, because Dr. Sanford asked me last week to work on a project, and I owe him a big favor since he's done so much for me. We're doing something on fitness, so I just have to postpone it. So there's the paper. The paper is, the link to it is in the video section. So a proper critique of this from, okay, so Leophilius says he's got books defending static universe, which we know is not static. He seems like something of a quack. All right, so there's circular reasoning there, Leophilius, because the static universe does have problems, but so does the expanding universe, such as the fact that they may have to resort to stuff like this. But like I said, the proper way to evaluate this is to actually understand the paper. And I've given you my limited understanding of this. I would welcome people to actually try to look at this and methodically comb through it. So with that, I'm going to see if I could go back to this. Okay, seems my video recovered a little bit. And I respect that if you don't want to believe it. Okay, but I at least provided, and then this was cited at least with some favorability by Hawkins. And Hawkins did do some observations with quasars and lack of time dilation. So, Leophilius says the expanding universe doesn't have problems. We literally observe it's expanding, dude. I'm sorry, Leophilius. Circular reasoning. This experiment, according to Hawkins, who published in the Royal Society, said this issue right here is the best evidence for expansion because it's trying to relate the redshifts to time dilation, and the prediction, according to Crawford, has failed. So, dude, I think you're resorting to circular reasoning. And if you were here yesterday, or yeah, when I was covering The Wonderful World of Disney, Michael Disney, he pointed out this table, and I think I should bring it up if I can again. I should have downloaded it. Oh, man. So, modern cosmology, science, or folktale. Oh boy. Okay, I think I'm going to have to just bring it up. If you'll pardon me here. Because I'm getting challenged on some things, and I think I need to try to at least say, I think what Leophilius said is wrong. It's not proven. That's exactly the point. You can keep making arguments by assertion as much as you want, but that's not a scientific. That's an argument by assertion worthy of a church. So let's see, Michael Disney's article. Open link in new tab. All right, so I'm going to get Michael Disney's article, and I'll show you the level of confirmation where you can definitively say that we have that this is the explanation to the exclusion of others. And he has a table here, and I put a modern cosmology, science or folktale. He has a table here that indicates if you have negative numbers, the claim is not confirmed to the exclusion of other theories. That's what they call the free parameters. And you can look at this and examine it yourself. And Michael Disney lists just about everything in the Big Bang has a negative number, some much more negative than others. And he said those are the explicit levels of freedom that need to be resolved. And he did include the implicit. He said you could add some more there. So let me see. Michael J. Disney. Michael J. Disney. And so the interested readers can look at that. He's Michael John Disney is an astrophysicist. He discovered the optical component of the Crab pulsar in 1969 with John Koch. And he's emeritus professor in the School of Physics and Astronomy, Cardiff University. He's done research on stars, pulsars, and quasars. So, and Leo says, I'm not making arguments from assertion. Just go review cosmological literature the last literally 100 years for yourself. Show me, I just showed you confounding data right there, at least what Disney says. And by the way, Leo, have you taken a class in general relativity and astrophysics and cosmology? I have. So, you know, I mean, at this point, your word is as good as mine. All right, so Leo, you know, I'm not gonna, I want to thank you for coming here and offering your contrary opinion. I'm just gonna have to, just for the sake of the other readers and listeners, just keep proceeding to give them, because my viewers might actually be interested to hear this other viewpoint, obviously, since many of them are creationists, particularly young Earth creationists, and even the old Earth creationists would like to hear some of this. So I've given this, did I show that page there? Yeah, all of these negative numbers in Michael Disney's paper, article, and I linked to it if anyone wants to see it. And they could see and he argues the free parameters are all negative. This is terrible for a robust theory. In comparison, if you look at real operational theories, like say Newtonian mechanics within its domain, meaning non-relativistic and macroscopic objects larger than the atomic quantum level, it works. You have numerous independent observations, bazillions of them, to confirm it. Same for classical electromagnetic theory within its domain and stuff like geometric optics. It works. Confirmed. Big Bang has not been able to resolve observations to the exclusion of other theories. The time dilation failure, 20 July 1944. I wanted to say I was at Cornerstone Church, 2 p.m. Easter Saturday. I was hoping you'd find me. I was sitting by Sandy Pigeon. I didn't know how to contact you 20 July 1944. I was there. I thought of you. If you were there, I hope you saw me. So, let's move forward. So the way to resolve this is to read the papers of both and decide for yourself. And I keep hearing you know, I've seen the same thing in evolutionary theory. They'll say, someone will come up with something, they'll say it's refuted, and it ended up not being. So I'm just going to leave that to your decision. And he may be an outlier. I'm an outlier. I reject abiogenesis theory and eukaryotic evolution. But I've had the experience of resisting the mainstream and knowing I was right. So let's move forward. That was Disney's paper. So what is one of a suggested mechanism, and I'm not saying this is right, but this only came out in 2021. And so let me look for the, I'm going to look at the docket here again. All right. Sorry about this. I have too many windows open and I'm just confusing myself in the process. Just give me a moment here. There was another paper by S.E. Leaning that also came to the same conclusion as Crawford. His was maybe a little earlier, so that's at least two. Now, for an alternate redshift theory, this came out in 2021, and I'm just going to share it. I'm not saying it's right, but it's one of the better ones that I have seen. And for those who've had, this was a little bit closer to my field of knowledge, but it's still over my head. We have someone from the Virtual Laser Application Design, LLC, and Department of Mechanical and Aerospace Engineering, Princeton University, Princeton, New Jersey. And this is an innocuous title. This is an innocuous title here because it actually deals with the Big Bang. Oh yeah, Mark, this is live, brother. 20 July 1944. Yeah, he said I was there at the 1600 service. I was at both services, 2 p.m. and 4 p.m. on Saturday. So I heard Gary Hamrick, and sorry, just a little bit because I don't see my friend here. Just as a side, I heard Gary Hamrick's jokes about like Yahweh, when the apostle said no way and Jesus said Yahweh, and then the thing about the cake that had paper towel stuffed in it, and Gary had to be the highest bidder to get it. So I was there, and I'm sorry we didn't run into each other, but I was there, brother. So it was great to know that I'd worshiped with you. So this has a very, it's a different perspective on the blue sky theory of single photon scattering on bound and free electrons. So for some people that are may be familiar with Compton scattering, which is the relativistic version of a photon hitting a charged particle. If the relativistic speeds of the charged particle, you get Compton scattering. But there's the non-relativistic version, which is Thomson scattering. Most people say that Thomson scattering, those mechanisms are not enough to cause redshifts, but kind of in a parallel level of reasoning, since there are lots of charged particles there, why don't I cut to the conclusion first, and then I'll build this up. And so I'm going to just keep moving forward, and I'll read it. So Andrew claims that they still found cosmological time dilation in type 1 supernova. Did they find any supernova that had no time dilation? Did anyone, this is not tired light. Please don't put words in my mouth, Andrew. That was Zwicky's 1929 thing. This is different. So the problem is they found cosmological time dilation in type 1a supernova. Did they find any that were non-time dilated, or did they just exclude it from their data set? That's the question. I mean, did they find any exceptions, or did they just filter those out? And what were their justifications for filtering it out? So anyway, they get to the Hubble constant at the end. So most of this is about the blue sky. But at the very, very end, boy, there's lots of electromagnetic theory and quantum mechanics here. The important thing about this is that Leophilius asked, how can you find supernova with no time dilation effects? Well, maybe you ought to look for it. Look for something that's redshifted that doesn't have time dilation. I gave examples of quasars. In Hawkins' paper, Monthly Notices, Royal Astronomical Society. So if you want to discount it because it doesn't agree with your ideas, that's fine. That's on, that's your privilege. All right, so let's see if I could get the Hubble. I should do this the more modern way. I need to do a search. Can I do a search? All right, here it is. I found it. So they're describing then how this redshift could be achieved. This would be consistent then with no time dilation. Currently in cosmology, the observed redshift of spectra of light emitted by distant stars is assumed to be due to the Doppler effect. It's Doppler-like is more proper. And they give the formula there, formula 37, where HO is the Hubble constant and U is the speed of the expansion of the universe. Equating the formula of 36 and 37 leads to the following formula for the Hubble constant. It is estimated that the average density of free electrons in the universe ranges from 10 squared per cubic meter in intergalactic space to 10 to the fourth per cubic meter in interstellar space. And they give the reference 24. A typical galaxy size is 30,000 light years, and the typical distance between galaxies is 10 to the 6th light years, reference 25. Using these distances to calculate the proportional contribution, we can estimate the average free electron density along the path of a light beam through the universe to be Ne equals 10 to the third per cubic meter. Substituting this equation number in equation 38 renders the value for the Hubble constant at approximately 68 kilometers per second per megaparsec. Is that right, Leo? MPC, megaparsecs? I don't know what the MPC stands for. Remarkably close to the current accepted range for the values of the Hubble constant, which is 69.8 plus or minus 1.9 kilometers per second megaparsecs, and 73.3 plus or minus 5.3 minus 5 plus or minus 5 kilometers per second megaparsecs. So, no blink out of paper so far. Great job at fixing that. No, I don't know what I did, Mark. I'm just maybe trying to just not overtax the system by hitting maybe too many keystrokes or scrolling. When I scroll, it can do that. So that is the claim. And you can see the paper here. And I think their opening is really good. So I'm going to point out the important thing is this can have, they obviously have worked in optics and lasers. They've proposed a laser experiment where we could actually see, we don't see it a lot, but we could, in theory, construct a system where we could actually see if we get this sort of reduction in frequency. There are any ways we can measure very slight changes in frequency. We certainly are able to do it with Compton scattering. We do have things like interferometers that might be able to detect a very small shift. So, in fact, we can even get shifts that are as small as what caused by hyperfine transitions. Only Albert Michelson, who's famous for his Nobel Prize on the Michelson-Morley experiment, was the first to detect hyperfine transitions. I don't know if this would be on the order of it. So they are suggesting we could at least test this idea in principle if we have an environment where we have unbound electrons and firing beams through it and seeing the reaction. So I like the fact we can test theory with experiment, which is more than I could say about expanding space, because, it's really hard to measure that. Same for dark matter. So anyway, so this one has a possible experimental validation. So we could settle a lot of arguments if we actually had the experiment and they have described, one can see from the paper how to deal with this. So okay, Mr. Jetty says scattering destroys spectral lines, but RedShift preserves them. I don't know about that. I don't know about that. Is that scattering destroys spectral lines? We're not talking about bound. So we're not looking at bound absorption. We're looking at free electrons. And where the photon is not necessarily re-emitted. Anyway, I'm just going to read through the theory. We present a theory of light scattering consistent with modern physics. We proposed a spatial temporal model of a photon based on classical model of an atomic oscillator. Using this photon model, we established a criterion for single versus multi-photon irradiation of matter. We demonstrated that the assumption that induced dipole radiation can be of infinitely small power is inconsistent with quantum mechanics. We proposed the energy criteria for scattering of a photon on a single and multiple atoms and free electrons. The criterion revealed the limitations of the applicability of Rayleigh and Thomson's models of scattering. According to our theory, light scattering is a threshold process, and the scattering can only take place for photons with wavelengths shorter than some threshold. Using our model, we computed the loss of energy by a photon with wavelengths longer than the scattering threshold during interaction with bound and free electrons. We showed that the single photon can lose energy in collisionless interactions with atoms, molecules, and free electrons. The new theoretical model predicts the redshift of photon wavelength resulting from such interactions. In particular, it provides an explanation for the blue color of sky and the alternate explanation to the cosmological redshift. I want to thank Mr. Jetty for his comment. In Streamlabs, I can't post comments to the screen. Otherwise, I'd post Mr. Jetty's for sure. Scattering destroys spectral lines, but redshift preserves them. Okay, so I'll just read this. A little bit outside of a science paper, but I'll read it anyway. Albert Einstein is attributed with the saying, "The important thing is not to stop questioning. It is a miracle that curiosity survives formal education." It is a miracle that curiosity survives formal education. Ostensibly, this is in response to a view that many accept what they are taught without exploring the why. That's why people accept evolutionary theory, even though it's terrible. In this progression, opinion becomes fact and evolves to foundational truth, like abiogenesis. And we advance our understanding, we must constantly check alignment of new ideas and concepts with foundational truths. If they do not align, then either the new concept is incorrect or the understanding of established science must evolve. The true scientist does not fear questioning either. The greatest advances of humanity occur not with incremental knowledge, but with revealing the foundation. Revealing the foundation may be different than what we thought. We suggest such a shift in foundational knowledge that aligns the theory of light scattering with modern quantum mechanics. Our work clearly explains why the Rayleigh and Thomson theoretical models are incompatible with modern physics. It is simple. We address the concepts found in standard textbooks, yet not trivial. The implications extend to other areas such as cosmology. Okay, so this is where it's tough. This has a lot of quantum mechanics and electromagnetic theory. I have never heard of, let's see, what did they cite it? What was it, Rayleigh? I mean, I've heard the name Rayleigh, obviously, and heard of Thomson, but okay, let's just keep going. Driven by practical need, we evaluated the Lorentz oscillator model, the LOM, and discovered multiple concerning shortcomings. First, LOM is unable to provide an accurate qualitative description of the physics of optical phenomenon. Second, LOM fails in the quantitative prediction of optical properties of materials, such as the refractive index and attenuation coefficients as a function of light frequency. Oh, okay. These terms have come up, but that is not my, that was certainly not my focus. So LOM fails in the quantitative prediction. LOM fails in the quantitative prediction of the optical properties of materials such as the refractive index and the attenuation coefficient as a function of light frequency. Since the Lorentz oscillator model is accepted as foundational for the major part of modern physical optics, we were compelled to investigate the reason for shortcomings. Again, one of them is a laser researcher. This is actually, I'm just going to pause here a little bit. I have a mathematical physicist. He's a professional mathematical physicist. I was thinking about calling him up today and working through this paper. So let's, I don't know that he has enough background. I know he has really good background in electromagnetics. So he would have the right skill set that if there's some parts of this, he deals a lot with in the radio spectrum. But I think there are enough principles here that would probably be, he should feel comfortable reviewing this paper with me and saying, Sal, I agree, I disagree here. He's very well versed in Lorentz theories, electromagnetism, relativity. So he's the guy. And so we'll see. So I'm going to report back what I discover if I'm able to get a hold of him. I can't reveal his name. He's in a very sensitive position, but he's very well qualified. If you hear me publish with him, it will probably have to be through a pseudonym. I'm sorry. So the investigation revealed two seemingly unknown facts. First, it appears Lorentz's model was based on the obsolete paradigm of J.J. Thomson's plum pudding atom. Second, according to Lorentz Nobel Prize acceptance lecture, the model that we now call the Lorentz oscillator model hinges on an assumption that ether exists and interacts with the electrons in an atom, causing friction-like loss of oscillation energy. Our investigation also revealed that since the creation of Lorentz model more than a century ago, there have been no research to evaluate whether LOM is consistent with modern physics paradigms. Instead, LOM was accepted without question in a vast body of very complex science built on this unverified foundation. It is as if history were repeating. Consider the sophisticated and notably accurate models of celestial dynamics that were built on the foundation of Ptolemy's faulty paradigm. The difference lies in our ability to test. Unlike Ptolemaic scientists who for the better part of a millennium had no experimental evidences confirming or denying the existence of the crystal spheres, modern physical optics scientists have easy access to multiple verified evidences that the atom is not like J.J. Thomson had imagined, and ether does not exist. I think the ether exists, but we'll move forward. During the past several years, we conducted an effort to replace the Lorentz oscillator model with a new atomic oscillator model that is consistent with modern physics, reference 3 to 5. In this work, one important issue came to our attention: the inadequacy of the term in the electron motion equation that describes the electron oscillation energy loss. At the beginning of the 20th century, Mandelstam, a contemporary of Lorentz, suggested that the oscillations of the atomic electron forced by an electromagnetic wave are damped due to the re-radiation from the induced time variable atomic dipole. Such a suggestion produced extensive letter exchange with arguments and discussion between Planck and Mandelstam during the first decade. This exchange was either unnoticed or most likely ignored by Lorentz, who continued with the ether friction energy dissipation. Surprisingly, in reference 7, surprisingly, the ether friction mechanism that models the damping term as proportional to the first-order time derivative of displacement remains in current textbooks as the mechanism for electron energy dissipation. Note that, beside being based on the obsolete paradigm of ether, such interpretation of the damping term contradicts modern electrodynamics. Indeed, the electron oscillation energy loss due to induced dipole radiation is proportional to the third-order derivative displacement, reference 8. Previously, we demonstrated that the seemingly insignificant replacement of the first-order time derivative with the third-order derivative leads to substantial consequences of both physics and mathematics nature. Thus, in composing a new atomic oscillator model, one of our foci was to write the re-radiation energy loss term correctly. Note that when formulated in the way proposed by Mandelstam, so this isn't really totally original Mandelstam, the way proposed by Mandelstam, the induced dipole re-radiation corresponds to the attenuation of the incident light due to scattering. Since the atomic and molecular scattering theory was developed by Rayleigh in the late 19th century, it is logical to question whether the theory was ever revised to agree with quantum mechanics. After all, quantum mechanics was created many decades after Rayleigh proposed his original theory of scattering, and more than one decade after he proposed his explanation for the blue color of the sky. Rayleigh's explanation for why the sky is blue is standard coursework in middle school physics, and numerous popularizers of science give detailed explanations. For example, reference 9. All indicators point to its acceptance as foundational knowledge. However, popular acceptance is not the same as proof in fact. So, we were driven to ascertain whether the seemingly established blue sky theory was ever reconciled with the foundational assumptions of quantum mechanics. As a result of our investigation, we can say with great degree of certainty that current scattering theories, Rayleigh's and Thomson's, are inconsistent with quantum mechanics. In particular, they are incompatible with the concept of a photon, the assumption of a quantized character of emission of electromagnetic radiation. In the sections below, we demonstrate that Rayleigh's and Thomson's scattering theories are inapplicable for low intensity light, such as in an unfocused laser beam, sunlight, or light emitted by an incandescent source, such as a candle, distant star, or other light sources of similarly low intensity. It is worth noting the importance of Rayleigh's contribution. He created a theory of scattering on the electrons bound in atoms and molecules by leveraging Maxwell's electromagnetic theory, which was novel at the time. This significant development laid a foundation for a large part of modern physical optics and led Thomson and Compton to develop their respective theories of scattering on free electrons. However, the use of these theories is limited to academic research that struggles to exploit them in experimental diagnostics that utilize scattering of high intensity coherent light of a laser. So there's a difference between high and low intensity light in the behavior. Additionally, we would like to make another note. Imagine irradiation conditions with an average light intensity that is significantly lower than typical focused laser beam intensities. One can suggest that under such conditions, the individual photons arrive to the potential scatterer without overlapping. Recall what many of us heard anecdotally from our university professors and physicist colleagues, that classical electromagnetic wave formalism corresponds to the multiple superimposing photons. Few realize that this formalism only holds when the intensity of light is above a certain threshold. Goodness, I did not know that. Okay. Anyone want to, probably viewing by recording, want to challenge that? That's pretty interesting. I never heard it characterized. I'm going to refer to my electromagnetic theory mathematical physics friend to see if I could pick his brain. And I'm trusting he's going to help re-educate me, kind of give me a retread on my physics understanding. That's really incredible. Electromagnetic wave formalism corresponds to the multiple superimposing photons. Few realize that this formalism only holds when the intensity of light is above a certain threshold. Few pondered the value of this threshold. Below, we will show that this threshold is high. For the irradiances below the threshold, we will propose a new theory of scattering that covers the full range of possible light-matter interaction conditions. The proposal is consistent with modern quantum mechanics. It includes scattering of a single photon. Obviously, such a general theory of scattering is radically different from what is found in modern optics textbooks. In particular, this new theory provides an accurate description of sunlight scattering of individual photons on atoms and molecules. Thus, this new theory replaces Rayleigh's explanation for why the sky is blue. And Mr. Jetty says, and in radio wave scattering is continuous. In the double slit experiment, a single photon is able to interfere with itself. There are two additional notes we would like for the reader to consider prior to the description of our approach. First, if one obtains a spectrum function as a pointwise product of the spectrum of radiation of black body with the temperature of the sun, the spectrum of scattered light as predicted by Rayleigh theory, and the spectral sensitivity of a human eye, the shape of this function will suggest that the sky should appear green to the human eye. See Figure 1 below. Second, our extensive attempt to find any peer-reviewed publications reporting the measured spectra of light scattered by atmospheric air yields zero output. Oh my goodness, okay. Thus we conclude that Rayleigh theory explaining the blue color of the sky was never tested, neither proven nor disproven. While surprising, a plausible explanation could be that Rayleigh's theory rapidly acquired the status of established science, rendering no interest in further investigation. After quantum mechanics was invented, the theorists were busy targeting more important problems, leaving the seemingly trivial and established blue sky theory behind. Okay, so yeah, I guess on the scale of things, why the sky is blue is, trying to revisit that is not on the high priority of physicists who are interested in other theories, like say inflation. So figure 1, our calculation of IBB, Planck, black body spectrum, IA Rayleigh, scattering spectrum, visible spectrum, human eye sensitivity in daylight, photopic is calculated based on data from reference 10. So they're arguing that we should be seeing green according to Rayleigh theory. Okay, so criterion for single versus multi-photon irradiation. First, let us explain the importance of such a criterion. The theoretical model of light scattering proposed by Rayleigh assumes a continuous function relation between the time-averaged irradiance, light intensity, and the amplitude of the sinusoidal time-dependent electric field. In simple terms, Rayleigh assumed that both the light intensity and the corresponding electric field amplitude emitted by an atom could take on values of any magnitude, including infinitesimally small values, continuously down to 0. Extending this assumption further, the scattering is the re-emission of the incident electromagnetic wave by the induced Hertz dipole, which can produce any intensity of light, including uber small. Thus, rephrasing the above, the assumption of Rayleigh's model is that light is always continuous, a continuous electromagnetic wave. Of course, at the time, the concept of photons was not yet introduced. Okay, so these are two things I have no familiarity with. The Rayleigh theory and a Hertz dipole. Any radio guys out there is welcome to explain what a Hertz dipole is. And Rebecca Davis is here. Greetings. Nowadays, the physicists who grew up with the concepts of the photon and the wave-particle duality of light know that when the average light intensity is low, the individual photons propagate in space without overlapping. If light indeed is a flow of photons, then the relationship between the time-averaged irradiance and the electric field amplitude differs from the above relationship formulated for the continuous conditions. Consequently, the induced Hertz dipole re-radiation model, which assumes the electric field amplitude value as continuously decreasing down to 0 with decrease of light intensity, would be inapplicable for the description of scattering of a single photon. Note again, the current scattering model remained unchanged since its creation by Rayleigh before the photon concept was coined. A gap between the current understanding of scattering and modern quantum mechanics. A gap exists between the current understanding of scattering and modern quantum mechanics. We propose to address this gap through developing a theory that includes a description of single photon irradiation conditions. As a first step, we formulate the criterion that clearly defines multi-photon and single photon irradiation conditions. In order to develop such a criterion, we need to introduce the characteristic time of the photon duration. This time denoted as T rad. Okay, T rad is the time of the radiation emission of Wellezug, a packet of electromagnetic radiation. Okay, that's the first time I heard of that term. Wellezug? And the radiation emission of a Wellezug. A Wellezug. What's a Wellezug? Wave packet of electromagnetic radiation by an emitter. For example, an atomic oscillator described as a Hertz dipole. Reference 6.8. From the equation of an electron oscillator with a damping force that is due to the emission of dipole radiation by the atom, reference 3.6, it follows that the duration of a photon with frequency omega is T rad, and you have it there, equation 1. I'm not going to read it. And Benrex is here. That some of these symbols should look familiar, like omega, frequency, and I think that's as zeta. That squiggly. Let me find out what that letter is. I have to look at Greek letters. What's that squiggly letter? That's a Z. I'm sorry, that's a Z? Z equals that this time of the photon's duration determines the spectral line width customarily called the natural broadening sigma v. Okay, we're trying to explain an alternative explanation for the redshift, just in case you know. So this would, if this is true, this would be, and they're able to confirm it experimentally through some sort of experiment here on Earth, that we can actually induce redshifts in this manner. It could possibly break the Big Bang. So I'm just explaining what this is. And this is a paper that only came out last year. So this could be very providential. Okay, so we're new, and lambda are the center line frequency and wavelength, and sigma lambda is the spectral line width. Okay, I have to find out what spectral line width means. Spectral line. Okay, spectral line width, I guess when you have a spectrum, you could see kind of the spectrum, the width of the spectral line. Okay, when you do spectroscopy. Okay, that's what I'm guessing here. Mr. Jetty said it's Z, Kz. Okay, Kz. An important note below, we will use the subscript int for interaction instead of the above subscript rad. The reason for that is as follows. The time of the radiation emission, Trad, is the photon's duration. Then this time is also the time during which the emitted photon interacts with the irradiated atom, molecule, or free electron, denoted below as T int. Thus, Trad is identically T int. If a flux of photons irradiates a plane that is normal to the propagation direction, the time between the arrival of the leading edges of the consecutive photons with center frequency omega to the plane is it's equation 3. And where I, lambda, is the spectral irradiance measured in watts per square meter nm. Watts per meter squared nm. Oh boy. Okay. I have some terms I need to learn. What spectral irradiance is and what that unit of W over m squared nm. And then we have the term, is that a sigma? Sigma lambda or delta lambda is the spectral line width. H bar is the Planck's constant. Is that H? H bar, I think that would be the reduced Planck's constant. Omega is the frequency, and S is the area of the atom photon collision cross section. Ben Rex, let me say a quick prayer for you right now, Ben Rex. Lord Jesus, Ben Rex is seeking to enter graduate school, and I thank you for all the graduate students that watch this channel, and aspiring graduate students, including Ben Rex. Lord, if it pleases you, grant him this. Even though his gain might be my loss, since I might not see him that much once he's in grad school, I lift him up in prayer. And Lord, there are other needs for people here in the chat. We give glory and honor to you for this stream. In Jesus' name, amen. So I'm just going to move on. If T and then pH is TPH. Oh, this is why it's so hard to read scientific papers, especially physics papers. I think that's time. TPH. All right, I'm just going to move on. This is going to drag down. This is how hard it is to read stuff like this. TPH is less than time interaction. The multiple photons overlap while arriving to the observation plane. And in this case, IL is proportional to energy squared, energy not squared, see figure 2. Greetings, C Gator. Wow. We're trying to show an alternative explanation for the redshift, which if we find one, it could take down the Big Bang. So I'll just keep plugging away here. The time of arrival of the consecutive photons is inversely proportional to the light irradiance. IL equals I lambda delta lambda. And for substantially large irradiance, TPH less than T interaction. It's starting to bother me. What is TPH? Okay, this is the time between the arrivals of the leading edges of the consecutive photons. Time between pH, the time between the arrivals of the leading edges of consecutive photons. So this is the time between the photons. I would have called it TBPH instead of TPH. Seagator, if it's a short question, I'll try to answer it. I want especially newcomers. If I'm not able to, I'll let you know. So go ahead, blast away and ask a question. In this case, assuming that all the arriving photons have the same phase, the photon flux could be represented as an electromagnetic wave with sinusoidal time-dependent electric field. E equals E naught sine omega t plus V. E naught sine omega t plus V. Oh, Benrex ought to recognize that. That's an alternating, that's like an alternating current. For such conditions, the current theoretical model of scattering created by Rayleigh should provide adequate description of scattering of a continuous electromagnetic wave on an atomic or molecular species. Similarly, for such conditions, a model created by Thomson should adequately describe the scattering on free electrons. Oh, okay, so now this is making sense. If TPH is less than the time of interaction, that means you're having continuous supply of photons that you can apply these formulas. In the case of low light irradiances, when TPH is greater than T interaction, the single photons arrive to the observation plane without overlapping. See the right wing figure, figure 2. In this case, the atomic or molecular scattering should be described as the scattering of a single photon. Prior to our work presented here, it appears that such a theory for single photon scattering has not been created. Oh my mathematical physics friend, professional mathematical physicist who specialize in electromagnetic theory should love this. Comparison of average light intensity IL and squared amplitude of electric field E naught for cases of multi-photon left 4 versus single photon right 2 exposures. The photons are represented as the red rectangles with the blue border. The light assumed to be formatted in pulses of duration t greater than the time between photons and time interaction, which could be either a finite duration, as in the case of pulse light, or infinite, as in the case of CW light. I think that's continuous wave. All right, so that'd be like a starlight. So let me look at this diagram. Okay, this is getting interesting. Is there a practical need to develop the theory of single photon low intensity light scattering, or does Rayleigh's theory of multi-photon scattering adequately is there a practical need to develop a theory of single photon low intensity light scattering, or does Rayleigh's theory of multi-photon scattering adequately describe most of the conditions of light scattering at the intensities ranging from focused laser light to sunlight? Use of the above equations 2 and 3 provide the answer. The division of equation 2 by equation 3 yields the ratio of the photon's duration to the time between the arrival of consecutive photons. So time interaction, time photon, and you get this other equation. That's an interesting equation, equation 4. The interaction between an atom and a photon can be treated as a particle collision. Then the interaction cross-section is S equals pi times the quantity squared of Ra plus RPH, where Ra is the radius of the atom and RPH is the radius of the photon. In the next section, we will consider in detail our proposed model of the photon. However, here, let us assume the characteristic diameter of a photon is equal to its wavelength. For the majority of practical needs, the shortest wavelength of an electromagnetic wave is at least several orders of magnitude larger than the characteristic diameter of an atom. Yes, okay, definitely for a radio wave versus atom. Okay. Several orders of magnitude larger than the characteristic diameter of an atom. Therefore, for our purpose, the atom-photon collision cross-section is S pi, and that is quantity lambda over z squared, and equation 4 can be written as such as equation 5. Oh, that's not z, that's 2. Sorry. Okay, you all can go to the video description section. You can download this paper from archive. This is good. So far, this is, I love the detail here. It's reassuring to see them go down to this level of detail. Then from equation 5, it follows that the threshold spectral irradiance of light corresponding to the transition from single photon to multi-photon interaction in units of that, whatever that is. I'm embarrassed to say I don't know what that unit is. Irradiance. I have to look up what irradiance is. I'm not an optics guy. Oh my goodness. I'm not an optics guy. So you have equation 6 where lambda nm is the wavelength of light in nanometers. Oh, okay. So they're multiplying that thing m squared times nanometers. Okay. All right. Never saw that before. If the spectral irradiance of light is lower than the threshold, then the single photon interaction takes place. If the spectral irradiance is larger than the threshold, then the interaction is multi-photon. And if it is significantly larger, then the electromagnetic wave formalism is applicable for the description of interaction. Using this criterion, we can ascertain that sunlight scattering in the atmosphere cannot be described by Rayleigh's model because it is suited only for multi-photon interaction. Indeed, the spectral irradiance of sunlight at the wavelength of 500 nanometers, for example, is approximately 10 to the 6 times lower than the threshold, see Table 1. Thus, the explanation for why the sky is blue, as provided by Rayleigh's model, is invalid. At the same time, if a beam of 0.1 millijoules, 100 nanoseconds, 10 nanometer spectral width, laser with wavelength 532 nanometers is focused into a spot of 10 micron diameter, the laser irradiance in the focal spot will exceed the threshold by more than 10 to the 6 times. In the latter case, more than 1 million photons will arrive to an atom at the same time. More than 1 million photons will arrive to an atom at the same time. And then Rayleigh's model is possibly applicable. Note that for an unfocused 10 millimeter diameter beam of the same laser, the spectral irradiance will be below the single to multi-photon transition threshold. And again, Rayleigh's theory of scattering wouldn't work. That's really interesting, honestly. I've not done a lot of optical physics. So this is a great learning opportunity. Thresholds, I'm going to call my physics friend not by his real name. I'll call him Hezekiah. Call him Hezekiah Wang. Okay. Oh, Hezekiah Wang. Threshold spectral irradiance, I'll have to ask him what handle he'll go by, but I'll call him Hezekiah for now. Threshold spectral irradiance for single to multi-photon scattering transition. Okay, so they'll do that. Let me pause here. There's also another paper I saw, an abstract, that there's a correlation between redshift and polarization. The more redshifted, the more polarization there is. This is for radio frequency observations. They might want to do a study whether they could reconstruct that polarization. If their model explains the polarization in correlation with the redshift, that would really strengthen this. There is some polarization, not much, in the cosmic microwave background radiation, which suggests to me it's not cosmic, it could be local. Just throwing that in there, because when we look at high redshift systems, there's a strong correlation with polarization. So just something to consider. And I'm really, once I talk to my friend Hezekiah and we go through this paper, I might then consider going to talk to these researchers. They're up in Princeton, New Jersey. I'd happy to, take them out to lunch or something and just go through this. Especially if Dr. Hezekiah, thinks this merits a lot. This is groundbreaking. I mean, it's just like such common sense. And they pointed out no one really cared about why the sky is blue. To revisit Rayleigh's explanation, why is the sky blue? And it's amazing this could explain the redshift in a way that's consistent with a non-expanding universe. In order to describe single photon scattering, we need to know the spatial temporal structure of a photon, i.e. we need a model of a photon. The structure of a photon, including its transverse and longitudinal size and electric field distribution, has received very little attention since its introduction by Lewis in 1926, reference 11. Only a few amateur scientists discussed the matter, and that was outside the peer-reviewed arena, reference 12 through 14. Oh, Mr. Jetty said that's not true at all. Were you referring to something I said? Anyway, I'll move on. I pay attention to anything Mr. Jetty said. He's very helpful. Only a few amateur scientists, discuss the matter. In the realm of professional physics, the number of publications that address the structure of a photon is also very small. For example, see reference 15 through 19. The opinion of the theorists, 12 through 16, is that both the longitudinal and transverse size of the photon are small, on the order of one wavelength or much smaller. I hope the side chat is saved. Was that referring to me? What this was? Okay, so they're saying that the longitudinal and transverse sizes of the photon are small, on the order of one wavelength or much smaller. However, in some very recent publications, experimental physicists, 17 through 19, presented measurement data indicating the length of the photon could be large, possibly exceeding many wavelengths. I don't know how we... That's interesting. Okay, this is all new to me, guys. This is where we're mixing classical electromagnetism with quantum mechanics. And Lord forbid I have to go into quantum electrodynamics. I don't know what, I wouldn't know what to do. Perhaps the lack of interest around the photon model is due to the apparent absence of a practical need to know the photon size and structure. However, in our research of the physics of atomic oscillators, oscillator interaction with an electromagnetic wave, we encountered a pressing need for a workable model of a photon. This stemmed from the attempt to answer the simple questions on whether sunlight interaction with air molecules is a single or multi-photon interaction. What may seem a naive question is of important practical nature. As we discussed at the beginning of the article, If the interaction of sunlight with an atom or a molecule of air is a multi-photon process, then the scattering can be described in terms of re-radiation scattering of electromagnetic wave by an induced molecular or atomic Hertzian dipole. If, however, the sunlight irradiance corresponds to a single photon interaction, then the current scattering model is inapplicable and the accepted Rayleigh explanation of why the sky is blue is incorrect. Okay, that's one of the novel things that they're proposing. What's the Hertzian dipole? Is that like the dipole that makes the dielectric constant in the capacitor? I don't know. In the above section, we introduced the equations 1 and 2 as an expression of the time of a photon's interaction with an atom. Let us assume that this time is the characteristic time of the Welle-Zug. I learned a new word today, a Welle-Zug. A Welle-Zug, a burst of radiation produced by an atomic oscillator. The radiation decay time of an atomic oscillator was first defined by Mandelstam, reference 6. I got to credit these guys. They went back like 100 years to some of the discussion between Lorentz and his colleagues. In the early 1900s, and 50 years later, it was described in detail in the theoretical physics textbook by Landau and Lifshitz, reference 8. Wow, these guys have combed the literature. I'm impressed. I may or may not have Landau and Lifshitz's book. If I did, I certainly didn't read it. I'm embarrassed to admit. Since then, it became a trivial concept taught to physics students, as in the case of the famous undergraduate course by Feynman, reference 20. Wow, these guys have combed every physics lecture and textbook. Not every, but a lot. Curiously, yeah, the Feynman lectures are like legendary. Curiously, in this lecture, Feynman mentioned that quantum mechanical considerations lead to the conclusion that the characteristic time of radiation emission by an atomic oscillator is in the nanosecond range. It is worth noting he did not provide any detailed analysis or discussion, and yet was wondering on the implication if an atomic oscillator emitting at 500 nanometers wavelength produces wave trains of nanosecond duration, then the photon with such wavelengths should be several meters long. The wavelength should be several meters. Wow, okay. So now we have a photon model. It is worth noting he did not provide any detailed analysis or discussion, and yet was wondering on the implication that if an atomic oscillator emitting at 500 nanometers wavelength produces wave trains of nanosecond duration, then the photon with such wavelength should be several meters long. Similar to Mandelstam and Feynman, we assume that the single photon is produced as a result of the spontaneous emission of a Welle-Zug by an electron in the excited state of an atom. The characteristic time of the radiation decay of the atomic oscillator emission multiplied by the speed of light is equal to the characteristic length of a photon. In the time domain, we suggest that a photon represents a burst of electromagnetic radiation with a given frequency, omega, an exponentially decreasing amplitude of the electric and magnetic fields with characteristic time of 1 over E decay, that is T interaction figure 3. This time T interaction determines the width of the spectral line of the photon emission, or so-called natural line width. Note that some physical processes, such as elastic collisions, could produce the jumps of the phase of atomic emission if the characteristic average time between the collision, T call, is shorter than the atomic oscillator radiation time, T int. The radiation phase jumps due to such collisions result in broadening of the atomic emission line. Note the process that neither add nor consume the energy of the atomic oscillator emission of the electromagnetic radiation, such as elastic conditions, would not change the characteristic emission time, T int, and therefore would not affect the length of the photon. Okay, figure 3. Temporal structure of a photon electric field is a function of time. emitted by an atom without collisions on the left, and undergoing collisions during the process of emitting on the right. Wow, that is really subtle. So they do give a different wavelength. It changes the structure. It is important to note the implications of our discussion so far. If the photon length is assumed to be much shorter than the length defined above, then from the criterion of single to multi-photon transition, equation 4, it follows that the multi-photon interaction simply doesn't exist. Indeed, for a photon that is smaller or equal to the wavelength size, in order for the accepted formalism of the electromagnetic wave to be valid, the irradiance levels would be unreasonably high. If the photon length is assumed to be much shorter than the length defined above, then the criterion of the single multi-photon transition, equation 4, it follows that the multi-photon interaction simply doesn't exist. Indeed, for a photon that is smaller or equal to wavelength size, in order for the accepted formalism of the electromagnetic wave to be valid, the irradiance levels would be unreasonably high. Okay, that's also interesting. That could be subject to experiment. To reiterate, if one rejects the supposition that the photon length is determined by the radiation decay time of an atomic oscillator, and instead one adopts the assumption that the photon length is one wavelength or less, one must conclude that the description of light as a continuous sinusoidal wave is inadequate for most known conditions. In particular, the assumption of a very short photon length leads to the conclusion that both Rayleigh and Thomson scattering theories are inadequate. This not only for irradiation, such as sunlight or unfocused laser light, as shown above, but also for focused laser light. So they're basically saying, the way that I read this, is the idea that the photon is long, has a long structure, is consistent with observation. So the actual length of the photon, the structure as far as length, width, height, it's not really been studied. It's not of a lot of practical interest up until now. So I really appreciate the rigor. In our further consideration of the structure of an individual photon, and you know what? I'm going to look forward to having just an evening with Hezekiah, Dr. Hezekiah, and we're going to just go through these pieces and learn bits of this paper, section by section. It could be a multi-evening deal. So anyway, in our further consideration of the structure of an individual photon, let us suggest that the field in the photon volume is linearly polarized, and the transverse, normal to the k vector, characteristic diameter of the photon is approximately lambda. So now, okay, so they focused in the previous paragraph on the length. Now they're dealing with the height or diameter of the photon, and they're just going to suppose it's the diameter of lambda. We suggest the transverse distribution of electric field amplitude has a bell shape, Gaussian for example, with a radius of approximately lambda over 2 on the 1 over e level. It is possible that the characteristic radial size of the photon in the directions that are parallel and perpendicular to the polarization vector are somewhat different. However, we suggest these characteristic transverse dimensions of a photon are closely approximated by the photon wavelength, or at least within the order of magnitude. Okay, so I don't know that they justified that, but we'll go with it. Assuming that the axis symmetric photon with Gaussian profile of the field amplitude and transverse radius that equals lambda over 2 on the 1 over e level of field amplitude, and taking into consideration the above discussion of the photon length, the spatial structure of the photon could be shown as in figure 4. I want to say this is the paper on the heavy electron quasi-particles, and this paper are very readable because it uses a lot of basic physics. the cosmology and astronomy stuff that is so specialized. So some of the papers I read, like Crawford's today, I would have a hard time getting through this. But so far, this is very nice. You know, we're just describing the height, you know, the length and the width and the height of a photon. And I think they're modeling it kind of like a cylinder. Or actually, they're showing a picture there. So there is their suggested spatial structure of a photon right there in XYZ coordinates. Spatial structure of a photon. Gaussian distribution of electric field amplitude is a function of the radial position in the cross-sectional plane XY with the characteristic radius lambda over 2, and the exponential decrease in longitudinal direction along the z-axis with the characteristic length c t interaction. Boy, I'd love to get together with Dapper Dino to do a Blender animation of this to help me visualize this and let the viewers visualize this. Let us now formulate a mathematical model of a photon. We formulate the set of equations that relate the electric field within the photon volume to the photon energy, starting from the equation for the time dependence of the maximum instantaneous intensity of the electromagnetic wave. Let me digest that. We formulate the set of equations that relate the electric field within the photon volume to the photon energy, starting from the equation for the time dependence of the maximum instantaneous intensity of the electromagnetic wave. I'm looking at this. This term here, I don't know if you could see my little cursor on equation 5. That looks like a decaying exponential. So you have a sinusoid here multiplied by decaying exponential. And Benrex should recognize this. Where do we have this situation? Definitely for the charging of a capacitor in DC, you have the decaying exponential. But to throw so let's say you have a sound wave and you build a circuit that's going to just kind of fade it out over a given time. That would describe that, something like that. Okay, decaying exponentials and sine waves, the bread and butter of electrical engineering. Where the commonly used notation for the constants is used. Omega is the radiation angular frequency. Phi, ram, t, and t call is the phase that is initially 0 and then takes random values that are changing at every collision of the radiating atomic oscillator. T call is the characteristic time between the collisions. See the above discussion in Figure 1. And as above, the duration of the exponentially decreasing amplitude of the electric field in the photon is T interaction. See equations 1 and 2. Then the energy of the photon is described by that. By equation 6, where sigma photon is the cross-section of a photon. If we assume the radial distribution of the field amplitude is approximately Gaussian with a radius of lambda over 2 and the 1e level, then the photon cross-section sigma ph equals pi over the quantity squared of lambda over 2 squared. Further, let us assume the characteristic time between the collisions that jolt the phase of the atomic oscillators is much larger than the time period of the radiated photon wave, i.e. T collision much greater than 2 pi over omega. Yeah, we see that 2 pi and omega a lot in electrical engineering. Then the integral of the radiation intensity in equation 6 can be estimated as follows. And I'm not going to recite what that monstrosity is for equation 7. Finally, the equation that relates the maximum amplitude of the electric field to the energy of the photon in our model is h omega. The E pH. Well, H, that's h bar omega. Okay, h bar omega, that sounds like the Planck-Einstein relation where energy equals h nu. Okay. Where the characteristic time of the emission of radiation by an atomic oscillator T int is defined by equation 1. Unfortunately, I don't see how we get anything out of equation 8. That looks too familiar, the Planck-Einstein relation. Anyway, energy criterion for forced dipole re-emission scattering of a single photon on an electron bound in a single atom or molecule or on a free electron. As discussed above, the present-day theory of scattering is based on a paradigm where the amplitudes of the electric and magnetic fields in electromagnetic wave could take values of any magnitude, including infinitesimally small values, continuously down to 0. This assumption is exactly the same as the Rayleigh-Jeans theory of black body radiation. This assumption is exactly the same as the Rayleigh-Jeans theory of black body radiation, which contradicts the measurements in spectral range of short wavelengths, and in particular predicts the ultraviolet catastrophe. Oh man, bravo! Okay, guys who studied quantum physics and black body radiation, bravo right here. They're connecting a famous problem in physics, the Rayleigh-Jeans model, in saying how, the one that Planck resolved and how it resulted in a disaster. They're now extending this to individual photon scattering. So bravo, gentlemen. Now we're talking. This is great stuff, man. This is physics nerd heaven. Bravo. Bravo. Let me just read this again. This was the highlight of my day. I gotta read this again. This is just music to my ears. This assumption is exactly the same as in the Rayleigh-Jeans theory of black body radiation, which contradicts the measurements in the special range of short wavelengths, and in particular predicts the ultraviolet catastrophe. Bravo. Of course, as we know, the assumption of continuously small radiation field amplitudes was replaced by the assumption of the quantum character of radiation. As a consequence of the quantized emission of radiation, there is a lower limit for the amplitudes of the electric and magnetic fields. This lower limit is determined by the energy of the photon and its volume. See figure 1 for more clarity. It assumes a tiny volume of the photon on the order of lambda cubed or less, as in reference 11 through 17. Then the minimum amplitude of the electric field would be rather large, and applying the above single versus multi-photon criteria, the photon overlap would occur at some unreasonably high light irradiances. This is awesome. They related the problem in, I guess, the late 19th century that Planck worked on. Planck won the Nobel Prize for studying ovens and black body radiation and solving the problem of the ultraviolet catastrophe by appealing to quantum mechanics. And what this paper is pointing out, that the blue sky explanation by Rayleigh is applying a kind of an inaccurate model, the same kind of inaccuracies that led to the Rayleigh-Jeans ultraviolet catastrophe. It needs to go from the classical fluid version of electrodynamics, which means you don't have quantized photons, to using quantum mechanics. And so far we haven't gotten into any quantum electrodynamics, thank God, because I don't have a clue about that. They're still using kind of a mix of classical electromagnetism with kind of accessible quantum mechanics here. And then, yeah, this is great. At the lower irradiances, the approximation of light-matter interaction as a continuous action of a sinusoidal wave should obviously be wrong, both quantitatively and qualitatively. However, if the volume of the photon is as large as as is suggested in our model, then the accepted theories of physical optics have at least some usefulness. They're applicable to the interaction of focused laser light for the multi-photon light-atom interaction. In the meantime, the case of low-intensity single-photon interaction still requires development of an adequate theory, as shown above. The irradiance of the sunlight is low, and therefore is outside of the area of applicability of Rayleigh's scattering theory. This is getting good. Now, let us present another argument demonstrating that Lorentz's model of the forced atomic oscillator and Rayleigh's and Thomson's scattering theories are inconsistent with the quantum mechanical paradigm of photons. In particular, our argument will demonstrate the impossibility of scattering as the re-emission of photons. Our argument is based on the supposition that quantum mechanics allows the re-emission of the electromagnetic wave radiation by the bound or free electrons only if the mechanical energy of the electron oscillations forced by the photon fields is no smaller than the energy of the photon. Okay, the mechanical energy of the electron oscillations is no smaller, so that means no smaller means it has to be bigger. So the mechanical energy of the electron has to be bigger than the energy of the photon. So there is a non-relativistic and relativistic version of the energy of the electron. The non-relativistic is, I guess, 1/2 mv squared. Or you could just use electron volts. So rather than the velocity of the electron, you can characterize it in terms of electron volts. So like you would kind of wind up into the definition of the value of electron volts. It's implicit the velocity of the electron when it's subject to a certain voltage over a distance, because the work energy theorem says the energy is the force over distance, and the voltage it'll work out that way. Anyway, okay, so the mechanical energy of the electron oscillations gives you the electron volts of the oscillations. It's not just the linear velocity, it's the oscillations. Is no smaller than the energy of the photon. Okay, I just had to think that out loud. Let us analyze the conditions under which an induced Hertz dipole can emit. First, recall that when a photon interacts with an atom, the electrons on the outer orbit are displaced from the equilibrium orbit and undergo force oscillations. This induced dipole is assumed to emit an electromagnetic wave. It is common textbook knowledge, for example, that the total power emitted by an oscillating dipole is, as in equation 9, where dO is the atomic dipole moment induced by the incident photon electric field, varying with time as a sinusoidal function with frequency omega. From a theory of an atomic oscillator, either Lorentz or ours, and assuming negligible loss, the amplitude of the dipole oscillations is equation 10. Where A naught is the amplitude of the electron oscillations and omega naught is the natural oscillation frequency of the atomic oscillator. Then the total emitted power is, as in equation 11. Oh boy, the math is starting to get hairy now. It was kind of tidy up until now. Let us assume, as in our model of a photon, that the electric field amplitude decreases with time as e to the minus t over t int. If we integrate over time, this gives the energy re-emitted by the atomic oscillating, undulating in the field of the photon as in equation 12. It looks like equation 12 and 11 are identical. That's okay, I don't know if that's right. In order to satisfy the quantum mechanics fundamental assumptions, this energy re-emitted by the forced atomic oscillator cannot be lesser than the energy independent of the incident photon that produces the dipole oscillations. If the frequency of the emitted photon is the same as the frequency of the incident photon, as in the case of elastic scattering, then the energy criterion of whether scattering is possible would be as follows, equation 13. And then you have that h bar omega, which I think is still the Einstein relation. I've never seen it in that form. Okay, just go on. In the case of a single photon interaction, the maximum electric field amplitude can be determined by the equation 8. And so we have equation 14, and that looks kind of ugly. Substituting equation 14 into equation 12 gives equation 15. Dividing both sides of equation 15 by the energy of the incident photon and taking into account criterion 13 gives us the following formulation of the energy criterion for scattering. All right, okay, that's equation 16. Assuming as above, the effective cross-section of the photon is that, equation 17. Then the elastic scattering of a photon by an electron bound in a single atom, what is currently referred to as Rayleigh scattering, is possible only for those frequencies of the incident photon that satisfy the inequality, where x is a dimensionless ratio of the photon frequency to the natural oscillation frequency of an electron in an atom. Then from equation 18, it is easy to see that the ratio n superscript SA and bound is either equal or exceeds 1 for those wavelengths that are shorter than approximately lambda naught, equals 2 pi c over omega naught. For the case of scattering on a single free electron, currently referred to as the Thomson scattering, the natural oscillation frequency omega naught is zero, and the criterion becomes as follows. And that's equation 19. Okay, I'm going to have to plow through that. I'm not expecting that I can understand it in this one sitting. I'm going to have to stare at that equation for like 20 minutes to figure it out. All of these equations. Let us apply the energy criteria 18 to the light scattering on molecular nitrogen. Previously, we demonstrated that for a hydrogen-like atom in the S state, the natural oscillation frequency of an atomic oscillator is omega naught approximately 2 VO over MERO squared, where U0, okay, U0 is the ionization potential and RO is the radius of the electron orbit. As a first approximation, we assume that the above expression for omega naught can also be used to estimate the natural frequency of oscillations of electrons responsible for photon scattering by simple molecules. Let us approximate the depth of electronic potential of molecular nitrogen with the value of its ionization potential U0 equals 15.6 electron volts. Another key parameter required for the accurate description of scattering is the value of the effective radius of the electron orbit, R0. First, we consider that photons with wavelengths less than 190 nanometers are strongly absorbed in the atmosphere by oxygen molecules. This is well documented and known as the Schumann-Runge absorption bands. Reference 21. Since the scattering of sunlight in the atmosphere undeniably exists, producing the observed blue color of the sky, the scattered photons are weakly absorbed as they propagate through the air. Subsequently, the wavelength of the scattered photon should be greater than 190 nanometers. The natural oscillation frequency is omega naught less than 9.92, 10 to the 15 radians per second. For a nitrogen molecule, such a value of the natural oscillation frequency corresponds to the value of the effective radius of the electron orbit. That is, R is greater than 236 picometers. This estimate of the electron orbit molecular nitrogen, 236 picometers, is close and exceeds by only 30% of the effective radius, computed based on the measured radius of the mean kinetic cross-section of the nitrogen molecule at 182 picometers. Simply put, the Rayleigh theory of scattering is inapplicable in the case of low light intensities that correspond to a single photon interaction. Regarding the new explanation of the blue color of the sky, the below conclusions follow from our new theoretical model of scattering. First, sunlight intensity is low, corresponding to a single photon interaction across the optical spectrum. Note that in the case of single photon interaction, there is no reason to consider the combined effect of constructive and destructive interference of incoherent fields of scattered radiation, since the wave of electromagnetic Willezug of a single photon is coherent. Second, estimation using inequality 18 shows that the scattering of a single photon on a single nitrogen molecule could occur only for the photons with wavelengths shorter than 200 nanometers. Okay, this is starting to get to the explanation of why the sky is blue. And we're finally at the halfway mark of this paper. I may, because it is very, very technical, I may or may not cover it again on this channel, although I'm tempted to. Why? Some people are asking me for an alternative model and trying to defend it. I'm doing that now. I invite serious critics, serious students of physics to examine this paper, and I put Mr. Jetty in that category. And let me see. Oh, I need to click on some of the links he provided. This is really good quantum mechanics and electromagnetic theory. And there's a lot of stuff that I'm just not familiar with that I need to spool up on. And I'm going to try to run it by Dr. Hezekiah Wang and see if this agrees. This actually is related to some of his work. I'd be very, very curious to see if he's dealt with this, because a lot of electromagnetic theory and electrical engineering is done classically. There's just a lot of it. And even when they built the first transistor, they didn't quite understand how it worked. Shockley won the Nobel Prize anyway. He was trying to build a junction field effect transistor. It ended up being a bipolar junction transistor. That's according to my professor. Okay, I don't have a reference for that. They needed quantum quasi-particle theory to explain why his would-be JFET ended up being a BJT. They needed a whole theory to do that. So this is very interesting. There's a time to be switching between kind of classical electromagnetism, and then you start going to the quantum, and you switch back constantly because the quantum stuff is obviously hard. And if you can build your models with classical, it's better to the extent you can. I mean, it's just better from a convenience standpoint, not necessarily accuracy. So I'd like to dedicate this stream to our Lord and Savior Jesus Christ, that gives us the scientific method that we can understand the construction of nature. At issue, and I've been vociferously contested in the side chat, they're insisting that space is expanding and it's so obvious. I'm just like, I don't think so. So we obviously have different opinions. But I think understanding the nature of our universe is important. It may or may not have theological implications. Let me just throw that out there. It may or may not. And it remains to be seen. Definitely for the young Earth creationists, if the Big Bang is false, they would be heartened. But ironically, there are some people that are advocates of an eternal universe that would also be heartened. So this discussion of all this quantum mechanics and electromagnetic theory and Rayleigh and Thomson scattering, to the extent this could explain the redshift as due to this atomic oscillator model versus an expanding universe, this could have big explanations, big impact on our view in our of ourselves in the universe. So praise the Lord for this day. And I want to thank all my friends that have suffered with me up until this point, both live and through recording. So with that, I'm going to close. Yeah, Ben Rex asked, can you make a stream on how variable speed of light is applied in a YEC model? There are multiple variable speed of light theories, and maybe since you requested it of me, that might be one of the up-and-coming streams. So I want to especially thank people who have been longtime members of this community and supporters of this channel. So you know what? Just so I don't forget, I'm going to write myself a note to do that. This is too important, and you're too much of a good friend. Let me do that right now. I'm going to put it on my list of to-dos. Ben Rex VSL. Okay. That'd be a great show. We could talk about all sorts of things. After all that, the YEC doesn't have models is one of the main reasons why I'm not a YEC. The YECs have some ideas. You can call them models. We are short, like everyone is, on data that would rule out one model in favor of another. And that's the same problem throughout all of the origin sciences. Although I think we can rule out naturalistic abiogenesis as any sort of even vague model. Same for eukaryotic evolution. So let's see. Let me move this up. I'm gonna close the stream now. Take care, and God richly bless you all. Have a great afternoon. And a special greetings to my friends in Europe who were with me for a large part of the stream. Take care.
Slipped the surly bonds of earth and danced the skies on laughter's silvered wings. Sunward I've climbed and joined the tumbling mirth of sun-split clouds and done 100 things you have not dreamed of. Wheeled and soared and swung high in the sunlit silence. Hovering there, I've chased the shouting wind along and flung my eager craft through footless halls of air. Up the long, delirious, burning blue, I've topped the windswept heights with easy grace, where never lark nor even eagle flew. And while with silent, lifting mind, I've trod the high, untrespassed sanctity of space, put out my hand, and touched the face of God.